Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the light emitting diode LED, and you all have already seen the LEDs. So LED is light emitting diode, and it emits the light and when it is used in forward biasing. So you can see first of all that whatever LED you are using, you know that LED is always operated in forward biasing. And due to this operation, we cannot use AC across LED. But obviously, we are plugging the LED into our home sockets which have AC flowing in them. So we know that there is a device which is called as rectifier, which we have already discussed, that is converting the AC into DC, and the transformer inside that device is step downing. It is doing step down function to step down the input voltage of 220 volt into the required LED voltage. Now, the symbol of LED, first of all, is like that. This is the symbol of LED. These two arrows shows that light photons are being emitted from this LED, and the LED is a heavily doped PN junction diode. This is a heavily doped PN junction diode, which has a large number of majority charge carriers. And in forward biasing, obviously, we have already discussed that in forward biasing, diffusion current flows through the diode, and diffusion current is due to the majority charge carriers, and those majority charge carriers, which are electrons and holes, are recombining with each other at the junction of the diode, and due to that recombination, photons are emitted from the junction of the diode. So this is the working of LED, and if those photons are in visible region, so we would see them in form of light. So this is light emitting diode. Now, how do we control the color of light which is emitted by LED? Now, obviously, we cannot change the color of a single LED. Now, I know that what is going into your mind. I would tell this in detail that why do we have some LEDs in which we press the switch, then color changes? Yeah, I know that. But the device or the LED which you are using in that case has multiple LEDs inside that single bulb, and when we are pressing that switch, the voltage across the different LEDs is changing. So let's suppose when we are pressing the switch for the first time, the voltage is shifted to the LED which is emitting the red light. So that complete bulb will emit the red light. Now again we press the switch to change the color, and again the voltage is shifted to the LED, small LED, which is emitting the green light. So that complete bulb will emit the green light. So LED is so small in size, so you could not differentiate that how many LEDs are there in a single bulb. But you always have noticed that in each that color changing LED light, it is mentioned that it can emit only these colors, either red, green, blue, or either this. So it is obviously fixed because the LEDs which are incorporated in that small bulb is fixed. We cannot change them. So we cannot change the color of a single LED because it is color of the LED depends on the base material which is used to create that LED. So if we are using the gallium arsenic phosphide, then it radiates red light. If we are using the gallium phosphide, then it radiates the green light. And while the materials like gallium arsenic or gallium arsenide, it radiates the infrared radiation. So the LED which we are using in our remote control in our home, where TV remote control is emitting the infrared radiation, and the base material that is used to make that LED is gallium arsenide. So the LED works on the low voltages, which is of 1 volt to 2 volt, and the current flowing in LED is 5 milliampere to 10 milliampere, and hence this LED consumes less powers. So we prefer always LED to save the power in our home, power consumption. So LED has a very important advantage that they do not require any warm up time. So they are fast in action. As soon as they are plugged in, they will glow with the equal brightness. And in bulb, you know that brightness eventually increases with time. At the now LEDs are very small in size, light in weight, and their life is very long. A single LED can can sustain up to 20 years. Okay, so this is very important to note. And now working of LED. Now we will discuss the detailed working of LED. So the LED diode, light emitting diode, is a simple diode, but there is a well type structure that is created inside the diode. I'll tell you why. But let us first of all discuss it as a normal PN junction diode. So this is P side and this is N side, and this is the junction or depletion region of the diode. So we have connected this N side with the negative terminal of the diode and P side with the positive terminal of the diode. So we have connected this LED in forward biasing. So in forward biasing, these holes which are in very huge amount because the doping concentration is very high, will be moving towards the junction in a large amount, and these electrons will be moving towards the junction in the large amount. So due to their movement, diffusion current will flow, and their holes and electrons will recombine at the junction. Due to this recombination, photons will be emitted from the junction. So it is very important to note that photons are emitted from the junction. And obviously, if we control the applied voltage, now you have already seen that we can also control the light intensity which is being emitted by a LED by varying the voltage. So obviously, if we vary the voltage, the diffusion current will change, and if diffusion current will change, then the number of majority charge carriers which are recombining at the junction will change. And obviously, due to recombination of one electron with hole, one photon will be emitted. And if the number of electron holes which are recombining at the junction will decrease or increase, the number of photons will decrease or increase accordingly. So we can control the intensity or the number of photon or the photon flux emitted by the LED by controlling the applied voltage. Now we cannot control the color of LED color of light emitted by the LED, by a single LED, obviously, because it depends on the base material of LED and we cannot change the base material. But we have designed such LED bulbs which has almost 3 or 7 LED panels, small, which has 7 LED which are emitting different colors, and by changing the trigger voltage on each LED we can trigger the different colors of LED. Okay, so that is how we can control the color of LED, and that is how we can control the intensity of light emitted by LED. Now this well type of structure is created due to the fact that if we have not created this structure, so this was a normal diode, this is a normal diode like that. So when these photons will be emitted from the junction, you would see that they would have to travel a large distance inside the material of the LED. And due to this large distance inside the material of LED, the probability of reabsorption of these photons is very high. They may be reabsorbed inside the material of the LED, and again electron hole pair will be created in the material. So these photons would not come out of the LED. So due to reduce this probability, we have created this well type structure, so that as soon as these photons are generated at the junction, they emits out from this LED and they can be seen as light emitted by the diode, and they may not be reabsorbed in the material of the diode. Therefore, this well type structure is created in the LED. Now this is the VI characteristic of LED. So VI characteristic is again the current voltage relationship, on in which current is plotted on the y-axis and voltage is plotted on the x-axis. So you can see that this is infrared LED, this is red LED, this is orange, this is blue. So you can easily see that the blue color and the violet color would be moving in the forward direction, which means that knee voltage for blue is greater than knee voltage for orange. Knee voltage for orange is greater than knee voltage for red, and knee voltage for red is greater than knee voltage for infrared. This is due to the fact that obviously the frequency h nu for blue will be greater than h nu for orange. We are comparing orange and blue. This is orange. And this is due to the fact that forbidden energy gap for the material emitting blue light will be greater than the forbidden energy gap for the material emitting orange light. Okay, so therefore we can say that we have already seen that the forbidden energy gap restricts the electron to jump from valence band to conduction band, and therefore we can say that knee voltage will be less than knee voltage for blue will be greater than the knee voltage for orange or infrared. Because you should remember that the forbidden energy gap of silicon is 1.1 eV and the knee voltage of silicon is 0.7 eV, 0.7 volt, and forbidden energy gap of germanium is 0.7 eV and the knee voltage of germanium is 0.3 eV. So the material which is having greater forbidden energy gap will have greater knee voltage. So this is the VI characteristic of LED. Thank you.